Hey guys, welcome to AdStruct. Today we'll talk about one of the most fundamental topic, centroid. Centroid is the point where all the area is concentrated in a cross section. For instance, in a circle, the center of the circle is the centroid of the circle. In rectangle, where the diagonals meet is centroid. From the centroid, let's draw a horizontal axis, which divides the rectangle in two equal parts. Now let's remove equal areas from both the sides. As area is still equal on both the sides of the horizontal axis, the centroid remains the same. Now let's remove the area of the bottom rectangle. In result to this, the centroid moves towards the bigger area. Here, one parameter which remains the same is the distance of both the areas from the horizontal axis. To bring back the centroid to the previous position, we can move the smaller area away from the horizontal axis. From this, one can understand that centroid depends on both area and the distance of that area from centroid. Now, let's generalize the concept to find the centroid of more complex shapes. The formula to find the centroid from any point is equals to the sum of product of area and distance divided by the whole area. This is weighted average of area. The sum of product of area and distance is known as first moment of area. Let's understand that. If we take a potato body of area A and considering a small area dA with the distances of dA from origin being x and y, the first moment of area in x direction is equals to Sx is equals to integrating over A x into dA, and in y it will be Sy is equals to integrating over the area y into dA. Let's apply this on a rectangle. First, we have to consider a point from where we will calculate the distances. Now for Sx, let's consider a thin strip of height h and thickness dx, which is at a distance of x. Now integrating over the whole length b, we will get Sx equals to integrating over the whole length multiplied by h into x into dx. Same we can do for Sy, taking a strip of length b and thickness dy, integrating over the whole height which is h. So Sy equals to integrating over h b into y into dy. Now integrating both Sx and Sy, we will get Sx equals to h into b square divided by 2 and Sy equals to b into h square divided by 2. Substituting both of these in the formula to find centroid, that is xc equals to sx divided by the whole area is equals to b by 2, and calculating yc, which is equals to sy divided by the whole area, becomes h by 2. Now let's apply this on an eye section. First we need to assume a point of reference from where we'll calculate all the distances. We'll call this assume centroid. Here, after taking point O on top left corner and considering a reference coordinate system, we will divide the cross section in three parts. Part 1, which is the top flange, part 2 web, and part 3 the bottom flange. As all the parts are rectangles, by just constructing diagonals we can find the centroid of all the three parts. We can observe that centroid of all three parts are vertically in same line, which is parallel to y. We can assume that x1, x2, x3 prime is equals to x prime. y1, y2 and y3 prime are the vertical distances of centroid of all three parts from the assumed centroid. Taking the weighted average, xc becomes a1 x1 plus a2 x2 plus a3 x3 divided by the whole area, and yc becomes a1 y1 plus a2 y2 plus a3 y3 divided by the whole area. We know that x1, x2 and x3 prime is equals to x prime. That's why we can take x prime common and whole areas will be cancelled. Hence xc is equals to x prime. And yc will be same, a1 y1 plus a2 y2 plus a3 y3 divided by whole area. By plotting xc and yc from the assumed centroid, which is point O, we can find the actual centroid. Thanks for watching the video. You can try to solve the on-screen problems. The detailed solution will be provided in the next video.